Ichthyosaurs, masters of evolutionary comeback. Ichthyosaurs represent one of the most remarkable evolutionary success stories among all animals, whether they lived on land or in the sea. These marine reptiles were among the first, secondarily aquatic, vertebrates, animals that originally evolved in aquatic environments, later adapted to life on land, and then, millions of years afterward, made a dramatic return to the ocean. But this return wasn't without cost. They had already undergone numerous adaptations to thrive on land, and returning to a fully aquatic life meant overcoming a host of new biological and physical challenges. One of the most complex obstacles faced by ichthyosaurs during their evolutionary journey back into the sea was reproduction. How could an air-breathing reptile, now bound to life in water, successfully reproduce in such a hostile and unfamiliar environment? Thanks to one of the most extraordinary fossils ever discovered, we now have an awe-inspiring glimpse into the reproductive biology of an animal that swam the oceans hundreds of millions of years ago. This is the story of how reptiles, once land dwellers, began giving birth in the sea. I'm Ancient, and welcome to Ancient Call. A new era of marine predators. For hundreds of millions of years, the oceans were ruled solely by fish. They were the only vertebrates patrolling the deep. Long after ancient armored fish known as placoderms dominated the seas, and long before killer whales ever appeared, a group of reptiles, once inhabitants of dry land, returned to the sea. In doing so, they took over the role of apex predators in the marine world. These reptiles, including ichthyosaurs, ruled the oceans for more than 180 million years, from the dawn of the Triassic period to the end of the Cretaceous. To achieve such dominance, they had to overcome a variety of aquatic challenges, but none was as crucial, or as mysterious, as their reproductive strategy. Successfully reproducing in a completely aquatic environment was essential for their survival and long-term evolutionary success. Ichthyosaurs, the fish lizards of the deep. The name Ichthyosaur comes from the Greek for fish lizard, and while they are among the most iconic marine reptiles ever discovered, they are often misrepresented as aquatic dinosaurs. This is incorrect. Ichthyosaurs were not dinosaurs at all. Unlike dinosaurs, ichthyosaurs had limbs shaped like fins, lived entirely in the water, and were anatomically very different in form and function. In fact, ichthyosaurs appeared in the fossil record nearly 20 million years before the first dinosaurs emerged. They were among the first large extinct reptiles to draw the attention of science. Much of what we know today is thanks to the pioneering work of Mary Anning, a legendary fossil hunter who collected hundreds of specimens during the early 19th century. Remarkably, the word ichthyosaur was coined at least 2 decades before the word dinosaur even existed. Despite their fish-like appearance, long snouts, streamlined bodies, and fins reminiscent of sharks or dolphins, we know from skeletal analysis that ichthyosaurs evolved from terrestrial ancestors. Early ichthyosaurs looked somewhat primitive and small, resembling finned lizards, while later species evolved into immense, whale-sized creatures. The Great Reproductive Puzzle. Because they were reptiles and had fins similar to those of sea turtles, early scientists once assumed that ichthyosaurs must have laid eggs on land. But this theory presented a major problem. Ichthyosaurs had become so thoroughly adapted to marine life that returning to land seemed physically impossible. Their body structure was far too specialized, such a trip would almost certainly leave them stranded. This led to an important question: did they lay eggs underwater like some amphibians, or did they give live birth, like mammals? And if they did give birth in water, how did they manage to do so without endangering themselves or their young? The answer would become clearer over time, thanks to fossil evidence and a series of incredible discoveries. Understanding how ichthyosaurs reproduced is not just a fascinating biological question, it also helps us unravel how reptiles readapted to an aquatic existence after living on land for millions of years. Clues in the fossils. The first major clue came more than 2 centuries ago, when paleontologists discovered ichthyosaur fossils containing smaller skeletons within their ribcages. Initially, many believed these were signs of cannibalism, that ichthyosaurs fed on their young or smaller members of their species. This idea was widely accepted for decades. However, As more specimens were unearthed, especially in Jurassic deposits near Holzmaden, Germany, the cannibalism theory began to fall apart. Some adult fossils contained up to 10 tiny skeletons inside them. Were all of these victims of predation? In 1846, a breakthrough came when collector Joseph Chawning examined an ichthyosaur fossil found in Somerset, England. This specimen, now housed at the Natural History Museum in London, contained a small, nearly complete skeleton located near the pelvic region, far from the stomach. This position made it unlikely to be a last meal. Instead, it suggested a completely different interpretation: live birth. This specimen may represent the world's first fossilized pregnant reptile. From controversy to consensus. The debate continued for decades until, in 1990, two landmark studies provided overwhelming evidence. The small skeletons inside the adult ichthyosaurs weren't prey, they were unborn offspring. They had been misinterpreted for years. None of the fetal skeletons showed signs of acid corrosion, and there were no bite marks. The odds of an adult eating so many juveniles whole, without chewing or digestion, were astronomically low. The idea that these were expectant mothers made perfect sense. To date, over 100 pregnant ichthyosaur specimens, particularly of the genus Stenopterygius, have been found in the Holzmaden region. In most cases, the fetuses are oriented with their heads facing the mother's head. This led researchers to hypothesize that ichthyosaurs gave birth tail first, similar to modern whales and dolphins, allowing the newborn to keep its nose inside the mother's body until the very last moment, minimizing the risk of drowning. This hypothesis was powerfully confirmed by one of the most breathtaking fossils ever discovered, a mother ichthyosaur caught in the act of giving birth. Tragically, the fossil captures the moment when one offspring is halfway through the birth canal, its head still inside the mother. The mother appears to have died during labor, resulting in the simultaneous deaths of herself and her 4 unborn young. It is a haunting and powerful scene, an ancient drama frozen in stone. A window into deep time. Another important discovery came from China, a fossil of the primitive Ichthyosaur Chaohurus, dating back to the early Triassic period, around 248 million years ago. This specimen showed a fetus emerging headfirst from the mother's body, with another newborn already expelled. This suggests that the earliest ichthyosaurs likely gave birth headfirst, as their terrestrial ancestors did, and that the tail-first strategy evolved later. This Chinese specimen holds the title of the oldest known fossil of a live birth among vertebrates, offering a direct window into the moment life began for a marine reptile almost 250 million years ago. The advantages of live birth. Giving live birth, also known as viviparity, gave ichthyosaurs a major evolutionary advantage. Their offspring were born fully formed, equipped with sharp, needle-like teeth, ready to hunt squid and fish almost immediately. Unlike whale calves, which depend on their mother's milk for nourishment, ichthyosaur babies were apparently independent from the moment they were born. However, this method of reproduction came with significant risks. The mother needed to consume vast amounts of food to sustain her pregnancy, and giving birth underwater was both physically demanding and dangerous. If labor lasted too long or complications arose, the mother would need to surface for air, a perilous moment that could result in drowning or make her vulnerable to predators. Many of the pregnant fossils we've found may be individuals who died from such complications. Their offspring, too, faced immediate challenges. Once born, they had to swim to the surface quickly to take their first breath. Still, despite the dangers, live birth proved to be a highly successful strategy, one that helped ichthyosaurs become dominant marine predators for nearly 200 million years. Legacy of the ichthyosaurs. Ichthyosaurs were the first large secondarily aquatic vertebrates to evolve this method of underwater birth. It was a bold evolutionary experiment, one that worked spectacularly well. Their journey from land to sea, and their ability to reproduce in water, stand as a testament to the adaptability and resilience of life on Earth. Through the stunning fossil evidence they left behind, ichthyosaurs continue to teach us not only about evolution, but also about survival, adaptation, and the timeless drive to bring new life into the world, even in the most unlikely of places.